All right, today's date is Monday, September 20th, 2021. This is for Algebra 2, going over some division questions that I assigned in class, but also for homework if you wanted to. This first problem, oh, by the way, I'm going to be solving the two different ways that we've learned in class using the area model and also, or guessing the rectangle model, tabular method, whatever you want to call it, and also long division. So this first problem, let's go ahead and start with the area model, the way that I taught us to do first. The way that I do this is the area. The numerator is the area of my rectangle. So I know if my rectangle, I have technology. Let's go ahead and use that really quickly. Let's go ahead and make a black outline, no inside. All right, there is my rectangle. On the side of my rectangle, I know that this side is going to be x squared, we'll say plus x plus 1, and then I can have lines in here to divide out. What's going to happen? I guess I can make those black lines as well. Definitely not equal, but that's okay. So x squared. I need to somehow get an 2x cubed. So let me put that in the top left. I'll put a 2x cubed. This area has to go somewhere, and typically it's going to be in the top left, which is reserved for the highest degree term. What right here do I put so that that number times x squared gives me 2x to the power of 3? Well, I needed 2 in there. 2 times the invisible 1 that's out here is 1. Or sorry, 2 times the invisible 1 is 2. And then I need x to the power of what? Well, 2 plus what gives me 3? 2 plus 1 gives you 3. So this is x to the power of 1, or just simply 2x. So I went through that kind of fast, and I apologize, but I have to be out of here in like 5 minutes. 10 minutes, I'm lying. And then once we figure out this side, then I multiply it all the way through. I know that this has to be 2x in order for that to be 2x cubed. Well, what is 2x times x? That is a 2x squared. Why? Because 2 times this invisible, I guess 1 goes right here, is 2. And x to the power of 1 times x to the power of 1, you add the exponents. 1 plus 1 is 2. Moving down, 2x to the power of 1, I guess 2x times 1 is just 2x. And I check how much of the area have I completed. I got the 2x cubed, that's right here. I have 2x squared, that's right here. And I have 2x, that's right here. I have the entire area. I don't even have to have a second column. I don't have a second column like this. I'm done. That is the entire area. And again, we're always after the other side length of the rectangle. So the answer here is 2x. Maybe I should box that in a red rectangle. This is the final answer. How would you do that with long division? I have a feeling I might not be able to do long division for all of these. They take kind of a long time. Well, I'd first set up 2x to the power of 3 plus 2x squared plus 2x, our numerator. That is being divided by our x squared plus x plus 1, x squared plus x plus 1. So the main goal of long division is to try to match this first term to get rid of it. So in order to match 2x cubed, I need to multiply this number, this leading term, by what? Well, again, I need a 2. So I'll put a 2 here. 2 times something, 2 times the invisible 1 is 2x cubed. I don't have the x cubed, though. I have 2x squared. If I add another x in here, now I'll get... this is x to the power of 1. 1 plus 2 gives me the 3. Again, when you multiply something with the same base of x, you add the exponents. Now I'm going to distribute 2x into these terms. 2x times x squared is 2x cubed. 2x times x is 2x squared, so plus 2x squared. And 2x times 1 is 2x, so plus 2x. And what do I do with this term? I subtract that whole term from the previous term. And those cancel out, those cancel out, those cancel out. I'm left with 0 after I subtract those terms, which means I'm done. And that is my final answer. This was one of the easier ones. That's why I gave it first. Either way, long division or the rectangle method gives us 2x. On to problem number 2, and I am realizing that I don't have enough time to go through each of these as thoroughly as I'd like. I'm going to do the rectangle method, or the area method, the tabular method. I don't know what name I'm giving this. Again, for this problem, let's grab a rectangle. About yay big, sure. All right, so I know one of the sides has to be 2x squared plus 1. This is probably too large. I realize that this is just a binomial, so I think that's probably a more appropriate size. I have 2x squared plus 1. And I'm after this side. If I have that side, I have the answer. I know that the area is 2x to the power 4 minus 3x squared minus 2. So usually this highest degree term will go in the top left, this 2x to the power of 4. So the question then becomes, what times 2x squared gives us 2x to the power of 4? Well, I already have the 2, so I don't need another coefficient. So my coefficient up here is just going to be 1. And then I need x to some power such that when I multiply it by x squared, I get x to the power of 4. And this is really an adding question. What number plus 2 gives me 4? The answer is 2 plus 2 gives you 4, so 2. And this is more easily written as just x squared. So x squared times 2x squared gives you 2x to the power of 4. Now that I figured out this column is x squared, I'm going to multiply that through, kind of like I'm distributing it into these two terms. X squared times 1 is x squared. And I'm done with that column. This one is obviously a little bit harder than our last problem. So let me draw our, I guess I could really extend, ooh, I don't like that, that's crooked. I could really extend this line out here. That would make more sense. There we go. So let's go ahead and check off our terms so far. Do we have 2x to the power of 4? Check. That's right there. Do we have a negative 3x squared? No. We just have an x squared. This is going the wrong direction. We want something that's negative, and we're going positive. That's why it's the wrong direction. So in order to make up for this wrong direction, I have to go backwards, or minus 4x squared. If I do minus 4x squared here, then these two together add up to negative 3x squared. So that has to be a negative 4x squared there. It can't go down here because then I'd have another x squared term right here, and those are like terms, which doesn't make sense. Each of these should be a non-like term for here and here. So that must be a negative 4x squared. And what times 2x squared, this what times this 2x squared gives you a negative 4x squared? And the answer is a negative 2 gives you a negative 4x squared. Negative 2 times 2x squared gives you a negative 4x squared. And continuing on with that logic, now that we know this column is negative 2 times 1 is negative 2. And again, check off your terms. These two added up to a negative 3x squared. Check. This adds up to a negative 2, it's just by itself. And we've got all three of the terms, therefore we have our answer. It's the side length, x squared minus 2. Unfortunately, I don't have enough time to do long division. I apologize. If I had more time, I would definitely do it. Number 3. I'll do long division for this one to show you how this one would work instead of doing the area model. So I'm going to do 5x cubed minus 2x squared minus 3x plus 4. That is going to be divided by x plus 1. All right, so again, goal, get rid of this term. To get rid of that term, when I have an x, I need to multiply by 5 and then an x squared. So I'm going to put a 5. I guess I can put it right here. 5x squared. I like matching the x squared and the x squareds one above and beneath the other. If I multiply by 5 times x, I'll get 5 with some x. And x to the power of 2 times x is x to the power of 3. You add the exponents. The exponent here is 1. Exponent here is 2. 2 plus 1 is 3. So I get a 3 here. And then distribute into the 1 as well. 5x squared times 1 is 5x squared. So plus 5x squared. What we just did here is we distributed this 5x squared into these two terms to get this binomial. Now that we've done that distribution, we're going to take this whole binomial and we're going to subtract it from this polynomial with 4 terms. We're going to subtract, and that's kind of like distributing the negative. So let me go ahead and distribute that. That turns that into a plus, minus, minus. That's how you just do your distribution. 5x cubed minus 5x cubed. As we hopefully did, we got rid of that first term. That was a whole goal of trying to match that first term. And negative 2x squared minus another 5x squared, they're both going negative, is going to be a negative 7x squared. Don't know why I've changed to yellow for that 7. I'm going to go back to blue. And I'm going to bring down the next term. I'm going to bring down this minus 3x. And the question then again becomes, how do I match negative 7x squared with just an x? And the answer is you multiply by a negative 7x. Because when you multiply negative 7x times x, you get a negative 7x squared. And when I multiply negative 7x times 1, I get a negative 7x. We're going to take this binomial and we're going to subtract it from the polynomial above. And when we do that, I'm going to distribute the negative by going like this, just changing all the signs. And negative 7x squared plus 7x squared is gone. And negative 3x plus 7x is a 4x. Go back to blue here, is a 4x. All right, almost there. Bring down the 4, and I have 4x plus 4 now. That should be a plus. And the question is then, how do I match 4x? Well, multiply by 4. So I'm going to say add 4 here. This 4 is going to be distributed into each of these two terms. 4 times x is 4x. And that was a terrible x. I'll try it again. And this 4 times 1, the final distribution, is 4. Again, we're going to subtract all of this, which means we're really distributing the negative. That's going to turn to plus, minus, minus. 4x minus 4x is gone. 4 minus 4 is gone. And we have no remainder. The final answer that we would have gotten with long division or with the tabular method is 5x squared minus 7x plus 4. And number 4 was really the hard one. I want to spend a little bit more time on it for those of you that are coming to the video solutions for this answer. This is phrased very differently than the three previous problems. How do you make sure that 3x minus 7 is a factor? That's a weird way of saying it. It just means that it is divisible without any remainder. It means go ahead and take 3x cubed minus 4x squared plus 5x plus k, and go ahead and divide it by 3x minus 7, but do it in a way where there's no remainder. This had no remainder. The remainder was 0. We want that 0. And I don't know the best way to do this. I see that it's really easy with long division. Maybe we should just try long division. If I have enough time, I'd like to do the tabular method at the very end as well. Let's do long division. Let's see what happens. So I'm going to do 3x minus 7 going into, hopefully I have enough room right here to write my answer, 3x cubed minus 4x squared plus 5x plus, I don't know, k. I'm just going to say k for now. Eventually we'll come back in and fill in that number. So let's go ahead and play around with this, trying to match this term. Again, if I multiply this by x squared, then I will get 3x cubed. So I'm going to put an x squared right here. That's a terrible x, right? I can do a little bit neater handwriting. X squared times 3x, and again, I'm distributing this x squared into these two terms. X squared times 3x is a 3x cubed. It should have matched that first term. Otherwise, we've done something wrong. And then finally, distributing into the negative 7 gives us a negative 7x squared. It's time to take this whole thing and subtract it. If I subtract it, I'm really distributing the negative, and the negative becomes positive. That becomes a negative. That becomes a positive. And go ahead and add slash subtract straight down. When we do 3x cubed minus 3x cubed, those are gone. Negative 4x squared plus 7x is a 3x squared. So far, so good. We did eliminate that first term. Bring down the 5x plus 5x. From here, we're trying to match this 3x squared term. I'm going to multiply just by x, so plus x. If I multiply x and again distribute into 3x minus 7, I should get a 3x squared minus 7x. Again, we're going to take that binomial, subtract it from the previous polynomial. Let's distribute that negative, plus, minus, plus. Again, it's just, distributing the negative is the equivalent of just changing all the signs. I think you probably picked up on that. 3x squared minus 3x squared, gone. 5x plus 7x is 12x. So this is going to be 12x. Bring down the k, plus k. All right, again, I'm trying to match that first term. What do I multiply this 3x by? By 4, so plus 4. All right, if I do that, 4 times 3x is 12x, and 4 times negative 7 is negative 28. Again, I'm going to take the whole thing and I'm going to subtract this binomial from the polynomial above. I guess it's a binomial from a binomial in this case. And I'm going to switch the signs, plus, minus, plus. And these need to add up to 0. Here's the key thing. They have to add up to 0 in order for 3x minus 7 to be a factor of this q of x, which is just that polynomial with 4 terms. So obviously the 12x and 12x canceled out. What should k be in order to get 0 here? Well, it has to be the opposite, whatever that is. The opposite would be negative 28. So your final answer here is k is equal to negative 28. So that's using long division. I'm really curious what that would look like with the tabular method. And I need to pick up Riley right now, but I want to do this problem. Give me like 5 minutes. Let's go ahead and add a new page to this. So I'm going to go here and say, add a new page, add page. Yep. And we're going to take that problem up here, and I'm going to, copy paste, shoink, copy paste that problem down here. How would I do this with the tabular method? So I know with the tabular method, I'm going to start out with a rectangle. I'm curious because I haven't actually done this problem. I don't know what would happen. If I start with 3x minus 7, I guess I made this rectangle too large, and I'm going to make it maybe that size. I don't know how far over to the right I'm going to go, so I'm going to give lots of room. I might not use it. I know that 3x and minus 7 are going to be one of the factors. So let's go ahead and make a line here. There's two sides, top inside and bottom side. I know that the top left has to be the biggest term, so that's going to be a 3x cubed. If that's 3x cubed, this must be an x squared. X squared, because x squared times 3x is 3x cubed. And then x squared times negative 7 is a negative 7x squared. All right, move down the chopping block here, shwink. All right, well, how many x squareds do I need? I need a total of negative 4x squared. By the way, we can check off this 3x squared. It's there. We do not have a negative 4x squared. We have a negative 7x squared, which is too much negative. We need to undo that a little bit to get back to negative 4x squared. How much? Well, we need to add a 3x squared, because 3x squared plus negative 7x squared, these two together make it so that we can check this off. Yes, now we have a negative 4x squared. Well, what must this column be in order for this to multiply by 3x to get 3x squared? By x. And then now that we have that column, you can say x times negative 7 is negative 7x. Good. Next column. I am going kind of fast because I assume you know what you're doing from the previous problems. I apologize if I am going too fast. Okay, well, we need to check off this 5x. We have negative 7x, which is going the wrong direction. We need to undo the 7x. We need to add 7x, and then we need to add another 5x. So these two cancel out and go to 0, and then we need to add another 5x here in order to check that 5x off. So let me go ahead and add those really quick. 7 plus 5 is 12x. So I'll come back here and I'll say, oh, that was really plus 12x. In order for that to be 12x, what is going to be multiplied by 3x to get 12x? Well, by 4. So that's 4, then 4 times negative 7 is negative 28. And that means that this area, all of this was the area, right? By the way, we checked off that 5x. All of this is area. Well, what is the area of that last spot? This always corresponds to the last spot. That last spot must be negative 28. And that's a cool tabular method. I was trying to think if there's like a shortcut to get that. Could you somehow know that was going to be 28? I don't think so. I think you have to go through all the math, either long division or with the tabular method to get that k is equal to negative 28. Well, thank you for sticking around. That concludes our unofficial homework. You're checking your understanding problems for tonight. I'll see you guys tomorrow.